How many 9-card hands have at least one king? Well, if you think about this, our card hand has two components, king and other. At least one king means one king, two kings, three kings, or possibly four kings. There are only 4 kings in the deck, so we stop here. And we want to have 9 cards in the hand, so if we have one king, we need 8 other cards. And then 2 kings, 7. So what this shows us is the makeup of the card hand. Now we know our card deck of cards, there are 4 kings in the deck, which gives us 48 other cards. Now at this point, we're ready to write down our answer. Now, card hands, we're not concerned about the order of the cards. Take the 9-card hand, shuffle up as much as you want, it's still the same 9 cards. So we're dealing with combinations. We definitely can't have repeats because you can't have the same card twice in the card hand. So we're going to look at each one of these as a separate type of card hand. In essence, it's a separate pile. So for 1 king and 8 others, combination. Of those 4 kings, pick 1. Of the remaining 48 cards that are not kings, we need 8. So there's our first pile. Second pile, 4 choose 2 times a combination 48 choose 7. And then finishing this off, and in actuality, the combination 4 choose 4 is 1, so we don't really have to include it in that last line, but it's there just to keep the form the same. Now another method to do this is to think about, well, in a card hand, all the possible number of kings would be 1, 2, 3, 4, or possibly 0. Well, if we have 0 kings, that means we have 9 others, and this hand right here is in essence what we don't want. Anytime you see the words at least or at most, we can always work the problem by total minus what we don't want. Total is how many ways can I pick any 9 cards. That's the combination 52 choose 9. And minus what I don't want. Well, I don't want the card hand that has 0 kings and 9 other cards. So there's one category of the don't want. Both of these problems, both of these methods will give us the same answer. Question 2 says, from among 80 light bulbs, 10 are defective. How many samples have at least one defective bulb? I can make a chart just like I did up above. So at least one defective is 1, 2, 3, 4, 5, 6, 7, 8 bad ones. And what I need to finish up my sample, because it has to have 8, if I have 1 bad I need 7 good. Now there are a total of 10 defectives to start with. And we have a total of 8 light bulbs, that means there are 70 good. So in the same form as we did above, each line represents a different style of outcome. So the combination 70 choose 7 times the combination 10 choose 1 plus combination 70 choose 6 10 choose 2. And following the form, we have all the rest of these. Now notice this is quite a lot to write down. Now if we had to compute this on the calculator, or if you wanted to compute this on the calculator, this would not be a fun one to do because it's a lot of computations. So if I look back at the original list, in terms of good and bad light bulbs, the only outcome I haven't listed here is 0 bad and 8 good. So from this problem here, these are the parts that we want. This one right here is the part we don't want. So if you made the chart out and decided, okay, what part do I want, what part do I don't want, notice the don't want is much smaller, it's a little easier to count. So if I do total minus what I don't want, well, total is picking out any 8 bulbs out of that group of 80, minus what I don't want, that's only that bottom row, which means I only have 3 things I'll have to type into the calculator. Oops, left off wrong number. So when you look at these, at least or at most, don't always assume that you have to use total minus what you don't want. It's not always the quickest. It depends on what you're trying to count. How many 8 card hands have at least 2 queens? So I can make my chart again. Now if you don't need to make the chart, that's fine. You can do it without it. But at least 2 queens means 2, 3, or 4 queens. Well, the other cards, since I have to have 8 cards, I'll have to pick 6 others if I have 2 queens, 5 others if I have 3, or 4 others. So doing what we did before, combination 4 choose 2 times the combination 48 choose 6. That's the first line. And then plus. There's a second line, and then our last line is that one right there. Now if we think about it, what don't we want in this case? We did not want 0 or 1 queen. So this is our don't want category. So if we do this problem the same way as before, in terms of total minus the don't want, now total is any 8 cards, so it's a combination 52 choose 8, minus the ones we don't want. Now notice there's 2 lines here, two rows. That means there's 2 different piles I'm talking about, which means I'll put a big bracket here. Combination 4 choose 0. Times combination 48 choose 8 plus the combination 4 choose 1 times the combination 48 choose 7. Now if you don't want the bracket, you could distribute the minus sign through, in other words, subtracting off each row from that combination 52 choose 8. Question 4. At a Boy Scout camp, where 2 boys from each of the states, we want to know, we pick a group of 4. How many ways can you get at least 1 boy from Maine? Well, if you get 1 boy from Maine and you want to have a total of 4, it means 3 others. 2 boys from Maine, which means 2 others. Now we know there are 2 guys from Maine and there's 2 kids from each state. So from the other 1, 2, 3 states, that means there's 6 from the other states. Combination 4 choose 1 times the combinations, 2 choose 1. So the combination 2 choose 1 times the combination of 6 choose 3 plus the combination of 2 choose 2 times the combination of 6 choose 2. Since we're picking a committee, we're not concerned about the order that they're in. And just as before, since we're talking about at least, we could also ask, okay, what do we not want? We don't want a committee that has nobody from main. So total minus what I don't want. Total is combination 8 choose 4 minus what I don't want. So there's two ways of doing this. Just got to pick the method you like, and the method that's easier. One card is drawn from a deck of 52 cards. How many ways can this be done if it is a king? So part A, now you're drawing one card, it's a card hand, so it's a combination. Well, how many kings are in the deck? There's 4 of them, and we want one of them. Now if you compute this out, you'll know this answer is 4. So in reality, if you're picking just one item, it's just easier to write down how many choices you have, instead of dealing with the combinations or the permutation. Part B says, how many ways can we get a king or a spade? Now, one thing we want to realize is there's a keyword here, and that keyword is or. King or a spade, in essence, union, or is union. So we could sort of keep track of this in our mind, or we could use this formula, king plus the number of spades minus how many kings and spades we have. Well, we know there are 4 kings in a deck, we know there's 13 spades, and we know that, well, king and spade, there's only one of those, the king of spades. So we get a total answer of 16. Now part C says king and a spade. Well, we just figured that one out, so that answers 1. Part D, how many ways can you get a king and a queen? Well, you're selecting one card. It can't happen, so there are 0 ways. Part E, not a king or not a queen. Notice the or is the important part again. So I can write this in my notation. Not a king would be king complement, or not a queen, that's queen complement. By the formula, this is the number of things that are not kings plus the number of things that are not queens minus the number of things that are not king and not queen. Now we know there are 4 kings in a deck. That means there are 48 cards that are not kings. Likewise, there's 4 queens, or it means there's 48 cards that are not queens. Now if you take your 52 cards, take out the kings, take out the queens, that gets you 44 cards. And if you crank all this out, you'll see the answer to this is 52. Now, it seems a little strange to have an answer of 52 with the whole deck is 52 items. But think of it this way. We have our kings, we have our queens, and we have other. Now when we say not kings, that's what I've underlined in purple. When I say not queens, that's what I've underlined in red. So I want not king or not a queen. Well, or means union, so I take everything underlined in purple, everything underlined in red, and combine them. Notice, based on our sketch here, it's everything. So once again, we have the or, a king or not a spade, doing this by formula. Using the formula to try to help keep things organized. If you're familiar with a deck of cards, you can sort of figure this out in your mind. We know there are 4 kings in a deck. We know in the deck there are 13 spades. That means there's 39 cards that are not a spade. And now we want to subtract off the things that are kings and not spades. Well, there's 3 of those. Simplifying this out to a final number, we get an answer of 40.